Welcome back to Daily Dose of Space. Even in an age of telescopes orbiting far above Earth and probes that have crossed the edge of our solar system, the universe still refuses to give up some of its secrets. The more we learn, the more we realize how much we still don't understand. And some mysteries seem to grow deeper the longer we look at them. Today, we're taking a look at a few of those mysteries, the ones that still puzzle astronomers, physicists, and cosmologists alike. They're not stories of science fiction, but real phenomena that challenge our understanding of how the universe works. Let's start with one of the strangest signals ever detected from deep space. Back in 1977, astronomer Jerry Ehman was scanning the skies using Ohio State University's Big Ear radio telescope, a massive structure listening for narrow-band radio signals that might hint at intelligent life. Most of what came through the system was random noise, static, background radiation, or signals from satellites. But on the night of August 15th, something unusual happened. For 72 seconds, the telescope recorded a powerful, narrow-band signal coming from the constellation Sagittarius, right near the center of our galaxy. It was strong, clean, and precisely within the frequency range that scientists expected a deliberate transmission to appear. Jerry circled the data printout in red pen and simply wrote one word beside it: "Wow." That's how the wow signal got its name. A moment of genuine human astonishment at something truly out of place. For decades, no one could explain it. It wasn't a known planet, comet, or spacecraft. No other telescope picked it up, and it was never detected again. Some argued it was a reflection of Earth-based interference. Others proposed it might have been a burst from a passing comet, but none of those explanations have fully matched the signal's strength and narrow frequency. The wow signal remains one of the most tantalizing clues in the history of SETI, the search for extraterrestrial intelligence. But perhaps what makes it even more intriguing is not that it suggests aliens are out there, but that it reminds us how rare and fragile signals like this are. In all the years since 1977, no one has detected another radio burst quite like it. Despite new telescopes, from Arecibo to the Green Bank Observatory to China's massive FAST array, that specific frequency and pattern have never repeated. Maybe it was a natural phenomenon we just don't understand yet. Or maybe it was a brief accidental whisper from somewhere unimaginably far away. Either way, the wow signal is a symbol of how even a single unexplained blip can inspire decades of curiosity. Now, speaking of mysterious radio signals, let's fast forward to the 21st century. Over the past 2 decades, astronomers have started picking up what seem to be distant cousins of the wow signal. But this time, they happen all the time, and they're far more powerful. They're called fast radio bursts, or FRBs. Each FRB is an intense flash of radio energy lasting only a few milliseconds. Yet, in that blink of time, it can release as much energy as our sun does in days. They come from galaxies millions or even billions of light years away. And for years, no one had any idea what was causing them. When the first FRB was discovered in 2007, it seemed like a glitch. Then more appeared, scattered across the sky with no clear source. Some repeated, most didn't. Every time scientists thought they understood them, a new one broke the rules. Today, thanks to observatories like CHIME in Canada and ASCAP in Australia, we've identified hundreds of FRBs. Many seem to come from magnetars, extremely dense magnetic remnants of dead stars. But not all of them fit that pattern. Some repeat in strange intervals. Others show polarizations and frequency drifts that no known astrophysical model can fully explain. There are even FRBs that appear to echo, their signals bending and scattering in ways that suggest something massive or turbulent between us and them, perhaps entire clouds of intergalactic plasma. The mystery here isn't whether they're artificial. Most likely they're not. It's why the universe produces them in so many different forms. FRBs might eventually help us map the cosmic web, the vast network of gas and dark matter connecting galaxies. Or they might reveal new physics of how energy travels through the cosmos. Either way, every burst we detect brings us a little closer to understanding the hidden structure of deep space. And while we're talking about cosmic mysteries that stretch across the entire universe, it's impossible not to mention the biggest one of all, dark energy. The invisible force that seems to be pulling everything apart. In the late 1990s, astronomers expected to find that the universe's expansion was slowing down over time. After all, gravity should gradually pull galaxies back together. But the opposite turned out to be true. When researchers studied distant supernovae, they found that the expansion of the universe wasn't slowing. It was accelerating. Something out there was pushing everything apart, and it wasn't ordinary matter, or radiation, or dark matter. It was something else, something we still can't detect directly. We call it dark energy, not because it's dark, but because it's unknown. Today, scientists estimate that dark energy makes up roughly 68% of the total energy of the universe. That means most of reality, most of existence itself, is made of something we can't measure, can't see, and can't describe except by its effects. Einstein once proposed a concept called the cosmological constant, a kind of energy of empty space that could resist gravity. It was meant to balance the universe and keep it static. He later called it his biggest blunder. But now it looks like he might have been right all along, that even in a perfect vacuum, space itself has energy that drives cosmic expansion. Modern missions like ESA's Euclid and NASA's Nancy Grace Roman Telescope are trying to measure how this expansion changes over time. Some data even suggest that dark energy might not be constant at all, that it could weaken or strengthen as the universe evolves. If that's true, it could mean that the universe's fate, whether it expands forever or collapses again, depends on a force we can't yet define. It's both humbling and inspiring, because despite all our progress, the thing that dominates the cosmos remains invisible to us. Then there's the cold spot, a region of the universe that's colder than it should be. When scientists mapped the cosmic microwave background, the afterglow of the Big Bang, they expected it to be fairly uniform, with only small fluctuations. But in 2004, data from the WMAP satellite revealed a massive patch of sky, hundreds of millions of light-years across, that was significantly cooler than the rest. Later, ESA's Planck satellite confirmed it. The cold spot is real. At first, astronomers thought it might just be a statistical fluke, a random low-temperature area caused by quantum fluctuations in the early universe. But the odds of that happening by chance are extremely small. Another idea was that there's a vast void, an enormous underdense region of space between us and that part of the cosmos, which makes it appear colder due to something called the integrated Sachs-Wolf effect. But even that doesn't seem to explain all of it. The cold spot might hint at something much stranger, maybe even a sign of interaction between our universe and another one, a leftover mark from cosmic inflation. There's no proof of that, but it's a reminder that our universe could be much larger and far more complex than what we can observe. Finally, let's talk about one of the strangest gravitational mysteries of all, the Great Attractor. In the 1980s, astronomers studying the motion of galaxies noticed something odd. The Milky Way, along with thousands of nearby galaxies, wasn't just drifting randomly. Everything seemed to be moving toward a specific region of space, a point hidden behind the dense plane of our own galaxy, in the direction of the constellations Centaurus and Hydra. They called it the Great Attractor, a gravitational anomaly with the mass of hundreds of thousands of galaxies pulling our local cluster toward it. The problem was, we couldn't see it directly. The Milky Way's own dust and gas blocked our view. Over time, infrared and radio observations revealed that part of this pull might come from a massive cluster of galaxies known as the Norma Cluster. But even that doesn't account for all of it. Beyond the Great Attractor lies an even larger structure, the Shapley Supercluster, one of the biggest concentrations of matter in the known universe. So the Milky Way and everything near it is effectively falling towards something enormous, something that might never stop pulling. It's a slow, cosmic drift on unimaginable scales. These mysteries, the wow signal, fast radio bursts, dark energy, the cold spot, and the Great Attractor, remind us of one simple truth. For all our technology and equations, the universe still keeps its deepest secrets well hidden. Maybe that's what makes astronomy so endlessly fascinating. Every answer leads to more questions. Every discovery deepens the mystery. And the best part? We're still just getting started. Thanks for watching, and as always, stay curious.